Okay, we are back. We are going to go ahead and take a look at J.J. Thompson. Remember, from Crookes, we learned that he figured out that that this green stuff in the Crookes tube, it was a particle. It was not a wave, and he did figure out that it actually did have some mass. So now J.J. comes along, J.J. Thompson, and he says, get the PowerPoint running. But he said that what he did was he held a magnet next to the Crookes tube. I have a little video of that. We'll see how it comes through in the Jing, because Jing's not taking a whole lot of frames per second of the movement. But we'll take a look at as this loads. And all this is a Crookes tube with a magnet being held by it. So you can see Crookes tube, you got the green stuff inside there. As he's moving the magnet, he can move the green field. So that means that whatever this green stuff is, it has some charge to it. And we found out that it's actually a negative charge that it has. So JJ said, well, here's the deal. We have a particle with a negative charge, and it does have mass. We know them today as electrons. This is significant because he really found, for the first time, he actually found a piece, a subatomic particle, a piece of an atom. Okay, he came up with a plum pudding model. The plum pudding model looks like, let's see here. It looks like this right here. This is plum pudding. Basically, it's plums floating around in pudding. And he said, well, what is that? It's just negatives in a sea of positives. So his model of matter was just negatives in a sea of positive. They're just all floating around with each other. I reference it sometimes in class. I call it the chocolate chip cookie model, because we have the chocolate chips, that could be all the negatives, floating around in a sea of positives. And you can also turn it around the other way. You could also call it positives in a sea of negatives. It's basically the same way both ways. Okay? Now, notice he discovered the negative particles. He never discovered the positive particles, but he assumed that they were there. Now, how can he assume that positive particles have to be there? Well, if you have your average student sitting in a chair in class or something like that, okay, nice little student right there, smiley, okay, good. Well, what if the student was negatively charged? What if all matter was just made of these negative particles that have mass? Well, the student would be negatively charged. The chair would be negatively charged as well. The student would repel the chair, and the student would come flying out. But would the student hit the ceiling? No, because the ceiling would be negatively charged. So the student would be, I don't know, levitating somewhere around in the middle of the room, stuff like that. Well, he wasn't floating around in his laboratory, and that's how he knew that there has to be a positive to go along with a negative. You can't have a neutrally charged material if you don't have a positive to balance out the negative. All right. That was JJ's contribution to this area. Next video, we're going to go ahead. We're going to start with Lord Rutherford, and we're going to take a look at his experiment and the three conclusions that he came up about atoms.